Alright folks, so in this video what I wanted to do is we will do a deep dive into the newly released DeepSeek R1 reasoning models. So if you are following the recent trends in the space of LLM, you will see that there is a lot of talk that is going on related to DeepSeek newly released model. So I thought about why not do a deep dive into this model, how the model works, what are the inner mechanisms you should know. So let's go into a deep dive into this DeepSeek R1 series of model. So what we will do is at first we will talk about what are reasoning models. Then slowly we will talk about the LLM training process. So that would be a recap of LLM training process. Then we will also do a recap of reinforcement learning and how reinforcement learning kind of fits into the space of LLM training process, and slowly we will move into the series of DeepSeek R1 models. So first we will talk about what is DeepSeek R10, how the model is getting trained with the help of GRPO and the rule-based reward mechanism, and then slowly we will talk about what are the issues of those DeepSeek R10 and how the DeepSeek R1, which is the popular model, came into the picture, and how the training process works in case of DeepSeek R1. And then we will, in the end, we will talk about what is a model distillation, as like DeepSeek also released few of the distilled model versions using this reasoning model technique. So all this we will go through in this video. So let's get started. First talk about what are reasoning models, right? So in case of reasoning LLM, the task of LLM to is to go beyond this simple text generation, and it should embrace the reasoning capabilities, right? So this LLM should be specially trained on performing the reasoning task, right? So the LLM can think through the complex situation and can make informed decisions based on the given data, right? So those tasks can differ. So some of those tasks are like logical deduction, then causal reasoning, and also solving the mathematical complex problems with the help of mathematical reasoning, right? So you can see this type of task typically requires the model to think in a step-by-step manner, and it should think with lot of time, with lot of reasoning to come up with a justified answer, right? So the training data, how the training data typically for this type of models are like, they should include a chain of thought prompting, which will force the LLM to think in a step-by-step manner and with the help of chain of thought process, right? The OpenAI's O1 series of model were the first to include this inference time scaling by increasing the length of the COT reasoning process, right? So this O1 series of models were the first released model which can do the reasoning on top of the given data, right? So but OpenAI release was totally closed release, so they haven't disclosed how they trained the model and what are the inner workings of that model. But with the help of this new released DeepSeek R1 series of model, now we know how to train this type of models, what is the training process looks like, what are the typical challenges that are associated with this type of models, right? So before going into the DeepSeek R1 series of model, let's talk about the typical training process of a LLM, right? So the LLM training process typically comprises of three steps. So the first step is where you do the language modeling, and you scrap a lot of data from the internet, and that can be a low quality data, and then you train a model which is optimized for text generation. So at this point of time, your LLM should be only able to produce the next token given a context, right? So then we get our output, which is nothing but a pre-trained LLM. So then comes the next step, right? So where we do the SFT phase, or the supervised fine-tuning phase, where we get like high quality data, and those data we generally call as demonstration data, and using that we kind of fine-tune the pre-trained LLM using a supervised technique, and we get an output where the model is what we call as SFT model, right? So now the model is kind of able to do a conversation task, and it will start making senses based on a given prompt, right? So after this step, the third step is the RLHF step, where we bring human in the loop, and using the human feedback we kind of create a comparison data, where using this comparison data again we train a reward model. So based on this reward model's feedback we use a reinforcement learning algorithm to update the model parameters of the SFT model, right? And if you want to go deep into the process of how this training process works, so I have few series of videos on this type of topic, so I will also link those videos in the description of this video, right? So now let's go through also a recap of RL, so which is nothing but reinforcement learning. So in case of reinforcement learning, these are the terminologies we should aware of. So first of all, the agent, right, which is nothing but the algorithm that we are trying to build in a particular environment, right? Then there is a terminology which is action, which is a set of possible action the agent can take being in a particular state, right? So after that what we have is a reward. So this reward is nothing but a scalar feedback which will tell us how well the agent is doing in a particular given state in the environment, right? So then we have this concept of state, which is nothing but the representation of the agent in the environment, right? So the goal of this reinforcement learning is to find out a policy which will maximize the reward, right? Now in terms of LLM, how we plug reinforcement learning, let's talk about that, right? So but before that, as we know, like this typical LLMs what we have, those typically generates one token at a time, right? So if I give a current context or a prompt to LLM, then the LLM will generate the next token, right? So that next token will be feedback to the current context, and the current context will be enhanced, and then again that current context will be fed to the LLM, and then again it will generate the next output token, right? So this process will go on till a particular length, or the finally the end of sentence token is generated, right? Now in terms of how we can plug the RL in terms of LLM, is that we can treat the current context as state. So that state is nothing but the representation of the current context, that we can call it as state. Then this LLM is nothing but the agent or the policy that we are trying to train, which will in the end which will generate the preference output given a prompt, right? Now the next token output what we can call as the action. So this is nothing but it will go into action space. So that action space is nothing but the vocabularies that we have, the tokens related to the full vocabulary that we have, right? So by taking that action, the LLM will get a reward. So based on the preference or the training mechanism, it can get a positive reward or a negative reward based on the next token that has been generated. And once that is done, by using a reinforcement learning algorithm, we will do the weight updates of this LLM, so that this LLM is more aligned with the human feedback, right? So as I mentioned, like the goal is to generate helpful and human preferred responses by training LLM with the help of RLHF, right? Okay, now let's jump into the series of DeepSeek R1 model. So we will start with this DeepSeek R10, right? So this DeepSeek R10 kind of takes this DeepSeek V3 base as kind of a starting model. Then it applies a large-scale reinforcement learning algorithm to came up with this DeepSeek R10 version. So this large scale RL is nothing but GRPO, and it this training process also does not comprises of supervised fine tuning process, right? This is also one of the invention of this paper, that without using a supervised fine tuning phase we can get a very state of the art performance by just employing reinforcement learning, right? So we will talk about in detail what this GRPO is, but let's see few of the characteristics of this DeepSeek R10. So this model, once it goes through large scale RL using GRPO. It demonstrates capabilities such as like self-verification, the reflection, and also it can generate long chain of thought prompts, right? By using this type of techniques like reflection and by generating long chain of thought prompts, it can solve very complex reasoning tasks, right? So the larger it thinks or the larger the chain of thought prompts it generates, the better the chance of generating more meaningful and correct answer, which requires a reasoning process in the given prompt, right? So if we can look into the system prompt, so we'll see that it starts with a message that this is a conversation between the user and assist, and the reasoning process and the answer must be enclosed within a think and the answer tags respectively, right? So it kind of tells you the model to include this think and answer tag. So the think tag is quite necessary because that's where the reasoning process will go on and it will generate the chain of thought prompting, and based on that it will try to come up with the answer, right? So with this two tags, we kind of ensures that the DeepSeek R10 will first produce a reasoning process, then it will follow up with the final answer. Right. So now let's talk about this GRPO, which is nothing but group relative policy optimization, which is typically used in case of the DeepSeek R1 training process. So aim of this GRPO is that by comparing within groups to optimize the policy model, and it will not need to train a value model or a critic model, right? So which will significantly reduce the computational cost because it does not require to train another model which will act as a critic. So this GRPO comprises of three steps, and the first step is where we will do the group sampling, where at first a given set of questions we will sample a question, and then it will generate a group of answers or a output, right? So and it will use the existing old policy to generate these outputs, which are nothing but O1 O2 till the given group size, right? So typically this group size is varies between 8 to 16. For this example, which you can see, given this math problem, it generated a few of the outputs. One of them, the first one, which is O1, that is the correct output, and rest of the outputs which is part of this group are wrong output, right? So then once this group sampling is done, then it also has a step 2, which does the advantage calculation, right? So the advantage calculation is where we allocate rewards based on the output correctness, right? So this advantage output is kind of an indication to the reinforcement learning algorithm that the whatever step it is currently taking, it is going in the right direction or not, right? So typically a reinforcement learning algorithm gives the final reward once all the steps are taken, and typically if you compare with a game scenario, so after the end of the game it will reveal the final reward. But in case of LLM, that is a uh, very difficult task to give the final reward at the end of the generation phase. But if you compare with the process of LLM, what it will do is once it generates a one output token, then it will see how that output token is compared with the other output tokens that are present in the vocabulary, right? And if that generated output token is in the right direction, then this advantage function will be a higher advantage value or greater than zero value, else it would be a negative value, right? So you can see the meaning is like if A1 is greater than 0, that means the O1 is better than the average level in the group, right? And if A1 is less than 0, then the performance is poor, right? So here the O1 you can treat it as the next output token that the LLM keeps on generating, right? So the aim of this GRPO is to come up with a policy which is pi theta and which will maximize the following objective function. right? So which is given here, right? So it looks like scary, but if you have gone through like the PPO or DRPO, so in those cases this function will be much more easier for you. So it has three components. So basically the first one is a strategy probability ratio. The strategy probability ratio is nothing but a ratio of the new probability distribution that we are trying to optimize with the policy that is the old policy that we have, right? You can denote the policy as pi theta, and then you have like O1 given the Q, right? So Q is here the question and O1 is the output. Ratio kind of reflects the difference in preference between the new and old strategies for the output, right? And then we have this cliff function which will limit the ratio which we have talked about in certain range. So this will prevent the output policy mutation, right? So we don't want our output policy to deviate from the actual policy. Then we also have the KL divergence, which takes in consideration the pi theta and also a pi ref. So this pi ref is the original LLM policy what we have. KL divergence kind of avoids the reward hacking process. So this reward hacking is typically when the LLM kind of generates an output through which it kind of gets a lot of rewards, but it kind of deviates from the base LLM policy, right? So using this scale divergence, you can make policy updates, but it should follow the reference or the base LLM's characteristics, right? So using these three things, we can get a more understanding of how the GRPO works. So this GRPO has typically few of these advantages. So one of them is like it is computationally efficient because it does not need to train a value model, which will save the memory or the computing power, right? So then it has the other advantages like training stability because it uses the cliff function and the KL divergence, which will ensure that there is a lesser policy mutation if you compare with the base policy, which is nothing but the base behavior of the LLM, how the LLM was trained. Then it also employs a rule driven reward system, which we will talk about in the next few minutes. So this rule driven reward model kind of rely on explicit reward rules to avoid the design of complex reward models, right? So here we don't need to train any reward models. By using this rule driven reward model, we can straight away apply the reinforcement learning algorithm, right? So then it also has a strong scalability, and it can be used for mathematical reasoning, the coding reasoning, or the logical reasoning task, right? So the training stability is mainly due to this, the concept of cliff function and KL divergence, which will avoid the policy to fall off the cliff, and it will try to follow the original base policy, but again it will make certain updates on the existing policy, right? So with this, let's talk about this rule-driven reward system. So this rule-driven reward system consists of two types of reward. So one of them is like accuracy rewards for deterministic results, where we need the deterministic results like mathematical problem. It will only give higher rewards when the final answer is in a specified format or it's a correct answer, right? So which this rewards will kind of measure the accuracy of the output that has been generated by the LLM. Then we also have this format rewards, which will enforce the model to put its thinking process between certain tags, right? So those tags are nothing but think, so which will ensure that the LLM should think in a step-by-step manner using the chain of thought prompting, and then it should generate the output. Now there are few observations which are related to this training process. So it has been seen during the training process that with larger steps, the average length per response also gets increased. That means the reasoning process or the thinking time of this DeepSeek R10 version shows a consistent improvement throughout the training process, right? So it will take more time to think, and then it will generate the answer. So then there is another uh, observation in the training of this DeepSeek R10, where they kind of notice that there is a aha moment. So this aha moment is nothing but where the model kind of thinks that it should reevaluate the steps it is currently executing, and based on that it will reevaluate, and then again it will start thinking in a more deeper manner, and then the answer would be generated. So you can see this, that it goes through this wait, that's a aha moment I can flag here. Let's reevaluate this step by step to identify if the correct sum can be done, right? So with this, the model kind of learns to allocate more thinking time to the problem by reevaluating its initial approach, right? This, the researchers have noticed that there is a self-reflection step which kind of helps this R10 version model to generate more correct and accurate answer using a aha moment, right? This also has few of these drawbacks. So this DeepSeek R10 kind of does well in terms of reasoning, but it struggle with few of the challenges. One of them is that the output that is being generated has a very poor readability, and also there is a problem of language mixing, right? So which the people are guessing that the chain of thought prompting which was used to train the model, the chain of thought prompts which has been used to train the model might have a mix of Chinese and English language. Based on that, whenever the model generates a final output in case of a new prompt or a new question, it will have a mix of Chinese and English, right? So this language mixing is always a problem. If to tackle this type of issues, they come up with this DeepSeek R1 version, which we will now go through, and we will see how the training process looks like in detail. So to solve the issues like lesser readability and language mixing, so they kind of come up with this DeepSeek R1 version where they kind of try to train a user-friendly model that not only produces clear and coherent chain of thought prompts, also it can demonstrate strong general capabilities, right? So what they do is they start with the DeepSeek V3 base, which was also used in case of DeepSeek R10 version. But here, in case of DeepSeek R1 model, they kind of followed a different path, right? So let's talk about that path. So what they do is at first they start with this cold start, where they kind of construct and collect a small amount of long COT data, and then kind of they fine tune this DeepSeek V3 base model, and they kind of get a checkpoint which will act as a initial RL actor, and this output of this checkpoint will kind of increase the model output readability, right? And in the step 2, what they do is apply the same reasoning oriented RL process which was also employed in case of DeepSeek R10 model, and this phase is kind of focused on enhancing the model's reasoning capabilities, right? And in the step 3, what they do is they do a rejection sampling and supervised fine tuning. So this supervised fine tuning phase is kind of different if you compare with the step 1 where we do kind of cold start. So how this step 3 is different, that initial cold start data which was mainly comprises of the reasoning data, right? But in this step what they do is they kind of incorporates data from other domains to enhance the model capabilities in terms of writing, role playing, and other general purpose tasks, right? So in this way they are kind of enabling the model to demonstrate strong general capabilities, right, with the help of this step 3 supervised fine tuning phase. And in the fourth step what they do is they kind of use reinforcement learning again, and that is more to do with aligning the model with human preferences, and this secondary RL stage is aimed at improving the model's the helpfulness and the harmlessness behavior, right? And also it will try to uh, simultaneously refine its reasoning capabilities, right? So in case of DeepSeek R1, the training process is a bit different. So it uses the RL base steps twice, and also it uses the supervised fine tuning phase twice, right? And with this we kind of get the final version which is nothing but the DeepSeek R1. In the paper they have also talked about this model distillation based on the reasoning model. Now let's try to understand what this model distillation looks on a high level. So what typical training process of any deep learning model looks like, that we kind of get a prediction from the model. Then we have the actual labels, and we kind of compare the predicted labels with the actual labels, and then we use a cross entropy loss to update the model parameters, right? But in case of this model distillation, what we generally do is we kind of use a teacher model, which is a fine-tuned teacher model, and we kind of get teacher logit outputs, and then we kind of compare the student logit distribution along with the teacher logits distribution, and we come up with a distill loss, right? So instead of only giving the actual labels as indication how the model weights should be updated, we kind of also use the teacher logits, which will give more signals to this less parameter student model to update its parameter in such a way that it kind of gives more or less similar results if you compare with the teacher model, right? So in the paper they have released few series of models. Those series of distilled models are related to Queen 1.5 billion model, Queen 7 billion model, and the 14 billion and 32 billion models. They have also kind of created the distill model in terms of 8 billion and 70 billion models, and we can see this if you compare with the performance of other reasoning models. These models are performing quite well, and the performance benchmarks are quite good if you compare with the other models, right? I hope you got a good understanding of what reasoning models are and how the DeepSeek R1 series of models are different if you compare with the traditional LLM training process. So I believe with this knowledge now you can go ahead and read the paper, and that will give you more insights on in terms of benchmark. So if you look at the benchmark, so this is how the benchmark looks, where you can see it has more or less similar performance if you compare with the OpenAI's O1 series of models, right? So with this, I will end this video. I hope you got a good understanding of this concepts. So thank you. See you in the next video.